The objective of this lesson is to find factors using area models. In this lesson, students will be using a rectangular array as their area model. An array has rows and columns in which the number of rows times the number of columns equals the total area. The numbers used to label the rectangular array are called factors. A factor pair is two numbers that multiply together to get a product. In this lesson, students started with this problem. At Molly's piano recital, there are 12 chairs. How can the chairs be arranged so that there are an equal number of chairs in each row? Explain your reasoning. Students were given square tiles or centimeter cubes to solve. Students may have come up with one row of 12 chairs, two rows of 6 chairs, 3 rows of 4 chairs, 4 rows of 3 chairs, 6 rows of 2 chairs, or 12 rows of 1 chair. These answers make up a rectangular array and describe the factors of 12. Students then discussed, how did they come up with the sizes? They might have said something like they knew that the rows had to be equal, and so they started with 1 or 2 rows and moved the cubes around to make an array. Are there any examples of the commutative property of multiplication? Yes. In this problem, there are 3 sets of commutative examples. The first set is 1 row with 12 chairs and 12 rows with 1 chair. Next, we have 2 rows of 6 chairs and 6 rows of 2 chairs. And lastly, 3 rows of 4 chairs and 4 rows of 3 chairs. The commutative property of multiplication states that changing the order of the factors does not change the product. Is this number prime or composite? 12 is a composite number because it has 3 or more factors, or in other words, it has 3 or more possible arrays. A prime number, such as 11, would only have 2 possible arrays, 1 times itself and itself times 1. Let's move on to one more example. A family size order of chicken wings contains 18 wings. How many people can have an equal number of wings? How many wings will each person get? Explain your reasoning. Using our total of 18 chicken wings, we need to make an area model. This model must have equal rows and columns. We can make quite a few different models. We can make a 1 by 18, 2 by 9, 3 by 6, 6 by 3, 9 by 2, and finally an 18 by 1. So we can see that one person can have all 18 wings, 2 people can equally share the wings and have 9 each, 3 people can each have 6 wings, 6 people can have 3 wings, 9 people can have 2 wings, or 18 people can each have 1 wing. The objective for this lesson was to find factors using area models. We met this objective by finding rectangular arrays of a number using square tiles or centimeter cubes.